Hello everyone, welcome back to our chemistry class. So we are still in chapter 3, periodic table. So this is the video of periodicity, part F. In this video, we will be talking about ionization energy. So ionization energy is the minimum energy needed to remove 1 mole of electron at the outermost shell from a gaseous atom or ion. So that is the general definition of ionization energy. So let's take a look at the first ionization energy first. So the first ionization energy is the minimum energy required to remove 1 mole of valence electron from 1 mole of neutral gaseous atom to form 1 mole of singly positive gaseous ion. So as you can see there from the equation, 1 mole of electron is being removed from the 1 mole of neutral gaseous atom to form 1 mole of singly positive gaseous ions. Meanwhile, the second ionization energy is the minimum energy required to remove 1 mole of valence electron from 1 mole of singly positive gaseous ion to form 1 mole of positive 2 gaseous ion. So the only difference is the charge of the ions. So we are removing 1 mole of electron from 1 mole of singly positive gaseous ion to form 1 mole of positive 2 gaseous ion. So the ionization energy is an endothermic process in which the energy must be supplied so that the electron can be removed. So the sign for the ionization energy is positive sign, and this will indicate that the energy is being absorbed by the electron. So as the ionization energy decreases, the metal become more metallic. So when we say the electron is easy to remove, so when the electron is easy to remove, meaning to say we only need a very small amount of energy to remove the electron. Therefore, we can conclude that the ionization energy is low. But when the electron is hard to remove, meaning to say we will be needing a large amount of energy to remove the electron. Therefore, the ionization energy will be increasing. So why is this happening? So to explain this, we are using the same atomic model that we used to explain the electronegativity in the previous video. Ionization energy is also highly affected by the size of the atom. So I'll be using a small atomic size and also large atomic size in the slides to explain the ionization energy in the atom. So we know that at the center of each atom we have nucleus, in which the nucleus is where the proton is located that have positive charge. We also know that when the atomic size is small, what is happening to the force of attraction? So actually, the force of attraction will be stronger when the atomic size is small. So when the force of attraction is stronger, the electron will be strongly held by the nucleus, in which case the electron is very hard to remove. So we will be needing a lot of energy to remove the electron. So when we are using a lot of energy, meaning to say the ionization energy also will get higher. When the atomic size is large, what happened to the force of attraction? So the force of attraction will become weaker. Therefore, the electron will weakly held by the nucleus. This cause the electron is very easy to remove. When it is very easy to remove, less amount of energy is needed to remove the electron. Therefore, the ionization energy will be lower. So as we go across the period, we know that the size of the atom will be decreasing. Okay, what is the reason of this? The reason of this, to explain, we are using the pizas. Okay, when we go across the period, the proton number will increase, the ZeV will be increased, and the attraction forces will be increased. This will cause the size of the atom become smaller. So when the size of atom becomes smaller, the energy needed to remove the electron is in high amount of energy. Therefore, the ionization energy will be increasing when we go across the period. However, when we go down a group, we know that the size of the atom will be increasing. What is the reason of this? The reason of this is because the ansatz. So as we go down the group, the number of shell will increase. The shielding effect also will be increasing. This will cause the force of attraction will be getting weaker. Therefore, the size of the atom will be increasing. So when the size of the atom is increasing, what happens to the energy? We will only needing a small amount of energy to remove the electron, the outermost electron. Therefore, the ionization energy decreases when we go down a group. So this is the full explanation about the ionization energy as we go across the period and as we go down the group. Okay, so we are still using the pizas and the ansatz to explain about the size of the atom, and cuma ada dua tambahan keyword sahaja daripada segi energy dan juga ionization energy. So we learned before, across the period, the ionization energy will be increasing. But as we look at the graph, we know that the increase of the ionization energy with proton number is not uniform. So when we look at the period 2 and also period 3, there are total of 4 cases in which the increase of ionization energy with proton number is not uniform. So this is what we call as the anomalous cases in period 2 and also period 3. So in period 2, there are 2 cases between beryllium and boron, and also between nitrogen and oxygen. While in period 3, there are 2 also cases between magnesium and aluminium, and also phosphorus and sulfur. So let's take a look at the first case between beryllium and also boron. So to explain these cases between beryllium and boron, you can choose either to explain why the ionization of beryllium is higher, or you can explain why the boron ionization energy is lower. It's up to you. Tapi untuk case ini saya akan explain kedua-dualah, kenapa beryllium tinggi dan kenapa boron rendah. So the valence electron shell for beryllium is 2s2, and the valence electron shell for boron is 2s2 to p1. So when we draw the orbital diagram for the valence electron shell, we know that for beryllium, the orbital diagram is completely filled orbital. But for boron, the valence electron shell is partially filled orbital. When we are looking at the valence shell electron for the beryllium, we can see that it is a completely filled orbital, and we know that a completely filled orbital is more stable. So when we remove one electron from the beryllium, it will make the atoms less stable. Thus, more energy is needed to remove the electron, and this will cause the ionization energy of beryllium is higher. as we look at the boron valence electron shell, we can see that the electron will be removed from the 2p orbital. This is because the 2p orbital is located further away from the nucleus when we compare to the 2s orbital of beryllium. Therefore, this electron will have less attraction to the nucleus and it will be easier to remove. Okay. Furthermore, when we remove the electron at the 2p orbital, it will make the atom more stable sebab tinggal di 2s saja bah. So less energy is needed to remove the electron. Therefore, the ionization energy of boron will be lower. Okay, now let's take a look at case 2. This is between nitrogen and also oxygen. So to explain, let us draw the valence electron shell for nitrogen and oxygen first. So for nitrogen, the valence electron shell is 2s2 2p3. So as we can see there, the nitrogen will have half filled orbital for the valence shell. While for oxygen, the valence shell is 2s2 2p4. So when we draw the orbital diagram for oxygen, we can see that oxygen will have partially filled orbital. And we know that the half-filled orbital actually is more stable than the partially filled orbital. So when we want to remove one electron from nitrogen, in the 2p orbital, it will make the atom less stable. So this will make more energy is needed to remove that electron. Therefore, the ionization energy for nitrogen is higher. As for oxygen, when we remove one electron from the 2p orbital, it will make the 2p orbital become half-filled orbital, and this will cause the atom more stable. Therefore, less energy is needed to remove the electron. This is why the ionization energy of oxygen is lower than nitrogen. So for the anomalous cases in the period 3 between the magnesium and also aluminium, and also between the phosphorus and sulfur, I will not explain it to you because the explanation is the same with case 1 and also case 2 punya explanation. So that's all for this video. Thank you for your time guys. I'll see you in the next video. Take care and bye-bye.